Dear students, welcome to mathematics online classes. In this class, we will see next part of section formula. Before going to problems on section formula, let me say one thing here. We know that suppose there is a line segment joining the points P and Q. OP is position vector of the first point P, OQ is the position vector of second point Q. Then position vector of point R, which divides PQ in the ratio m:n, is given as position vector of point R. OR is equal to, we know this as m into vector B, in the sense m into position vector of second point plus n into position vector of first point divided by m plus n. This is the formula we have studied in the previous class, where position vector of point R we took it as vector R. Vector R is equal to m into position vector of second point we took as vector B plus n into vector A divided by m plus n. This concept we have studied in the previous class. Now suppose you see, if R is midpoint of the line segment PQ, then what happens here? Then m is to n will be there, m is to n will be 1:1. Midpoint in the sense whatever is there on the left hand side, same thing will be there in the right hand side of the point R. Hence m is to n ratio will be 1:1. In that case, what happens to the vector R? Vector R is equal to, m is 1, so it is vector B, this is vector A divided by 1 plus 1, means vector R is equal to vector A plus vector B. Just I am writing B plus A as A plus B, because vector addition is commutative. 1 plus 1 is 2. What we can say with this? Position vector of, I am writing here, position vector of midpoint of line segment, joining P and Q, whose position vectors are A and B, is given by vector R is equal to, this is midpoint, position vector of midpoint, means suppose there is points P and Q, R will be the midpoint here. In that case, whatever is there left hand side, same thing is there on the right hand side. That means vector R is equal to, here we will be having vector A plus vector B by 2. This is position vector of midpoint. Yes. Now we will take problems on this. Insert the textbook, example number 11 I will take. Example 11. Consider 2 points. P and Q with position vectors. Vector OP is equal to vector 3a minus 2b and vector OQ is equal to vector OQ is equal to vector A plus vector B. Full stop. Find the position vector of point R. Find the position vector of point R which divides the line joining, P and Q in the ratio 2:1. First case internally and second one externally. I will take first case, that is internal division. See, there are 2 points P and Q. There are 2 points P and Q like this. OP is position vector of the first point, OQ is position vector of the second point. Find the position vector of point R. Somewhere here will be the point R, depending on the which type of division it is. If it is internal, it will be in between PQ. If it is external, outside the PQ. In the ratio 2:1, M:n ratio is equal to 2:1. Now first case internally. What is that internally formula? Formula is position vector of point R is vector OR. I will take like this. Vector OR is equal to, how we should remember formula, M into position vector of second point. It is P and Q, in the sense P is first point, Q is a second point. We should remember this formula as a position vector of the point which is dividing the PQ is equal to M into position vector of a second point plus N into position vector of a first point divided by M plus N. This is how we should remember. Okay. Now position vector of point OR is equal to, what is M? M is 2 and they have given a OQ. OQ is vector A plus vector B plus N is 1 into OP is 3A minus 2B whole divided by M plus N, means it is 2 plus 1. 2 will get multiplied with these two. 2 into vector A plus 2 into vector B plus 3 into vector A minus 2 into vector B. You see, plus 2B minus 2B get cancelled, whole divided by 3. This is vector 2A plus vector 3 into A divided by 3. How much is this? 2 plus 3 is 5. 5 by 3 into vector A. What is this? This is position vector of the point R which is dividing PQ internally in the ratio 2:1. Now we will take the second part of the problem, that is external division. Second one, external division. That means the point R which is dividing PQ is not lying on the line. If we extend this line, that point will be there. Okay. Here I hope you know the formula, that is position vector of point R is, we should write it as vector OR, which is equal to, how we should write, same way, M into position vector of a second point. What is M into second point here? Second point is vector OQ means position vector of second point Q is OQ minus of n into position vector of first point, that is vector OP divided by m minus n. This is how we should remember. Okay, now you substitute all this. M means 2 into position vector of second point, that is OQ is vector A plus vector B minus of n is 1 into OP is 3A minus 2B all divided by m minus n means 2 minus 1. 2 minus 1 is 1, denominator part is 1, no need to worry. Numerator part is 2 into vector A plus 2 into vector B minus 1 will get multiplied with these 2 minus 3 into vector A minus minus plus 2 into vector B. This is plus 2A minus 3A is minus A, 2B plus 2B 4B. You see, position vector of the point R which divides PQ externally in the ratio 2:1 is minus vector A plus 4 times vector B. This is about example 11. Now we will take the next example, that is example 12. Example 12, it is given as show that the points A of 2i minus j plus k, comma B of I minus 3j minus 5k, comma C of 3i minus 4j minus 4k are the vertices of a right angled triangle. Vertices of a right angled triangle. Okay, now read the question once again. Show that the points A of, B of, C of, these are the points. Show that the points they are saying, you have to be careful, are the vertices of a right angled triangle. See, I will write a right angled triangle here like this, which is A, which is B, which is C, I can't say, roughly I am writing it here. This is A, B, C. If I take like this, what is this 2i minus j plus k? Some of you will get confused with the points vectors and side vectors. These are points in the sense they are saying that a point they are given, that means 2i minus j plus k is a position vector of point A, that is position vector of point A. Position vector of point A in the sense this, if you join from the origin O like this one they have given you here vector OA is 2i minus j plus k, vector OA, position vector of point A. And what is this that I minus 3j minus 5k, that is position vector of point B. Some of you will get confused, like we will take AB as 2i minus j plus k, BC as that another one vector, CA as third vector, like that we will take. That is wrong. Here they are saying that points. Show that the points means these are position vectors. And then what is that I minus 3j minus 5k, that is position vector of point B. Position vector of point B means the vector which is joined from origin to the point B. That one they have given you. It is not A, B, B, C. Then OB is I minus 3j minus 5k. Then what about OC? OC is 3i minus 4j minus 4k. Position vector of all 3 points they have given you. I will erase this part, it is not required. I wrote it just to make sure you understand this. Now, can we find out side AB? I am going to find out side AB here. Side AB is nothing but what? Side AB is a vector joining 2 points A and B. Vector joining 2 points where initial point is A, terminal point is B. Vector joining 2 points. I hope you know this will be equal to position vector of second point minus position vector of first point. OB minus OA. What is OB? OB is I minus 3j minus 5k minus of OA. OA is 2i minus j plus k. Okay. Now we will subtract it. I minus 2i is minus I, minus 3j minus minus plus j is minus 2j, minus 5k minus minus into plus. So here minus is there, minus 6k. What is this? This is vector AB. To show a triangle is a right angled triangle, what we do? We use a Pythagoras theorem. What is Pythagoras theorem? Pythagoras theorem is square of hypotenuse is equal to sum of squares of other two sides. Here square of hypotenuse, that means what? Length. Here we are speaking about square of length. What is the length of the side? Length of side is nothing but magnitude of the vector. Let us find out magnitude of vector AB. Magnitude of vector AB is square root of, here minus 1 is there, minus 1 square plus minus 2 square plus minus 6 square. This is square root of 1 plus 4 plus 36. This is equal to what? This is equal to square root of 41. What is this? Magnitude of vector AB. That means length of side AB it is. We want squares, to use the Pythagoras theorem. Let us square on both sides. We have magnitude of vector AB square is equal to 41. Let me take this as 1. And now coming to side BC. How will you find out side BC? Side BC is nothing but a vector joining 2 points B and C, where terminal point is C, initial point is B. Vector joining B and C will be written as position vector of point C minus position vector of point B. Then now you write OC. OC is 3i minus 4j minus 4k minus of OB is I minus 3j minus 5k. Yes, now you subtract 3i minus I, that will be 2i minus 4j, here minus minus it will be plus 7j minus 4k, here minus minus plus 4, this is minus 4 plus 1 plus 5 means it is plus 1. What is this? This is vector BC. Now let me find out length of this vector BC. Length of the vector BC is nothing but magnitude. What is this? Square root of 2 square plus 7 square plus 1 square. Square root of 2 square is 4, 7 square is 49 plus 1. This one we got square root of 54. Sorry, we went wrong here. I will correct it here itself. This is minus 4j, minus minus it is plus in the sense minus 4 plus 3 is minus 1 it is. This is minus 1j. Minus 1j means it is minus 1 square. Minus 1 square means it is plus 1. How much is this? This is the square root of 6. Magnitude of vector BC is square root of 6. We want square of the side, as we want square of side, squaring on both side, BC square is equal to 6. Let us name this as 2. Now we will find out a third side, length of third side, that is vector CA we will find out. CA you can take AC also, no problem. Anyhow we want the length here, not the vector. CA is OA minus OC. Vector CA is equal to, what is OA? OA is 2i minus j plus k minus of OC is 3i minus 4j minus 4k. Yes, subtract 2 minus 3 is minus I, minus j plus 4j is plus 3j, k here plus 4 means it is plus 5k. This is what? This is CA is equal to, vector CA is equal to. Now magnitude of vector CA is square root of minus 1 square plus 3 square plus 5 square, square root of 1 plus 9 plus 25. 1 plus 9 plus 25. How much is this? This is square root of 35. Magnitude of vector CA is square root of 35. Now CA square is 35. Now are we getting sum of square of two sides is equal to third side? Yes, you see this is third one. Adding 2 and 3, adding 2 and 3, we have BC square plus CA square is equal to 6 plus 35. 6 plus 35 is 41. 41 is nothing but AB square. So here we have AB square. This is what? BC square plus CA square is equal to, you see, square of hypotenuse is equal to sum of squares of other two sides we are getting. Therefore the given points form a right angled triangle. Here we will write the sentence, otherwise let me write it here. Therefore the given points form a right angled triangle. This is about example 12. Okay, now we will move on to the exercise. Exercise 10.2 we are going to deal. Exercise 10.2, first question. Compute the magnitude of the following vectors. Compute the magnitude of following vectors. Three vectors they have given you. First vector is vector A is equal to I plus j plus k. What about its magnitude? Okay, I have to write it in blue pen, Yes. magnitude of the vector is equal to square root of 1 square plus 1 square plus 1 square. This is nothing but square root of 3. Magnitude of vector A is square root of 3. Very simple it is. In the same way, they have given you two more vectors. Vector B is equal to, it is given 2i minus 7j minus 3k. I hope you will solve this. Magnitude of vector B is equal to square root of 2 square minus 7 square minus 3 square. Now, and then vector C is equal to 1 by root 3 into I cap plus 1 by root 3 into j cap minus 1 by root 3 into k cap. You find out its magnitude also. I hope you will do this. I will move on to the next question. That is question number 2. Exercise 10.2, question number 2. It is given as write two different vectors. Write two different vectors having same magnitude. Two different vectors having a same magnitude. See, they are talking about different vectors having same magnitude. First of all, we will revise what is equal vectors here. What do you mean by equal vectors? Two vectors are equal if they have same magnitude and direction. If any one is different, they will be different vectors. They will not be equal vectors. They are saying that write two different vectors having the same magnitude. Magnitudes should be same. Like that you write two vectors. Let me write very simple. Answer is vector I and vector j. Do they have the same magnitude or not? Yes, they have the same magnitude. Its magnitude is 1, its magnitude is also 1, square root of 1, that is 1 only. And what about the direction? Yes, direction is totally different. I is in the direction of x axis, j is in the direction of y axis. So, this is the answer. Now, going to the second question. This is second question only. Going to third question. Write two different vectors having same direction. Third question it is, write two different vectors having same direction. Direction should be same, but they have to be different vectors. Like that I have to write two vectors. What are those? See, I will write the answer very easily. Direction should be same, Let us take one vector as I. Again it should have the same direction. Magnitude should be different. Let me take a 2i vector. Magnitudes are different because it has the length of 1 unit and this 2i has the length of 2 units. And what is same here? Same direction. Both are in the direction of x axis only. Like this we can write. We can write any answer like this. Any answer we can write. This is about question number 3. Now, we will take question number 4. Question number 4 is, find the values of x and y. Find the values of x and y. Find the values of x and y. So that the vectors 2i plus 3j and xi plus yj and xi plus yj are equal. See, there are two vectors given to you. These two vectors are in component form. Two vectors are given in component form. If two vectors are in component form, how means when they will be equal? They will be equal when their corresponding components are same. Here given 2i plus 3j and xi plus yj are equal vectors. When they will be equal? When their corresponding components are equal. These two vectors are equal in the sense x should be equal to 2 and y should be equal to 3. This is the answer. Yes. Question number 4 over. Taking the next question, that is question number 5. Question number 5 is find the scalar and vector components. Find the scalar and vector components. Find the scalar and vector components of the vector with initial point 2, 1, with initial point 2, 1 and terminal point minus 5, 7 and the terminal point minus 5, 7. See, scalar and vector components I have to find out. There is a vector like this. Its initial point is, let us name it as A. Its initial point they have given you 2, 1 and its terminal point is also given to us. Its terminal point is minus 5, 7. What I have to find out? I have to find out its scalar and vector components. Let us find vector AB first of all. To find out vector AB, what we need? This is a vector joining 2 points. Vector joining 2 points is nothing but position vector of second point minus position vector of first point. What is the position vector of these 2 points here? Here vector OA is, it has the coordinates 2, 1, only x and y are there. Write x and y, no problem, no need to write z. This is 2i plus 1j. What about the vector OB? Vector OB is minus 5i plus 7j. Now vector AB is equal to OB, you write minus 5i plus 7j minus of OA is 2i plus j. Okay, we will subtract minus 5i minus 2 means it is minus 7i, here 7j minus j plus 6j it is. Okay, I found the vector joining the given points 2, 1 and minus 5, 7. Now our question is to write scalar components and vector components. What are the scalar components here? Scalar components are minus 7, here 6. Scalar components are minus 7, 6. And what about the vector components? Vector components are, what are those? Here minus 7i and here 6j. This is about a 5th question, I think. This is about a 5th question in the exercise 10.2. Remaining questions we will take it in the next video. Thank you.